Okay, so tonight we're going to be continuing our talk about solving systems of equations, but this time we're going to be diverting away from solving with substitution, and we're actually talking about solving using the elimination method when we have to add. So this is a different method by which to solve a system of equations that's different than graphing, that's different than substitution. You know, we talked about graphing, and we got to the point where graphing became really laborious when we didn't have some of our equations in slope-intercept form. When we get to substitution, sometimes when we have fractional coefficients, or when we have to go ahead and solve and isolate a variable, whether that's x or y, it doesn't matter, um, for one of the equations, then it becomes more laborious. So elimination method can be really, really helpful when we have equations like we do here with 3x minus 5y is equal to negative 16 and 2x plus 5y is equal to 31. Both of these equations are currently in standard form. So when I have two equations, this one and this one, both in standard form, this is really elimination method is really helpful. I'm gonna zoom out for a second. I'm gonna go ahead and rewrite these because I'm gonna show you why this is really beneficial. I'm gonna change to a different color marker here. So the elimination method basically says I can eliminate one of the variables. And I can do that by adding or subtracting the complete equation to or from the other one, and by doing so, eliminate one of the variables. So if I look at what I currently have here, I see that the coefficients for y are negative 5 and positive 5. I know that these are additive inverses of each other. So because they're additive inverses, I'm going to go ahead and I'm actually going to add these equations together. Now that sounds really kind of counterintuitive, or can sound counterintuitive, but if I watch what I'm doing here and I do this carefully, it saves me a lot of trouble. So what I'm doing is I'm adding the coefficients for each one of the variables. So in this case, I take 3 plus 2, and that is going to give me 5x. Alright, if I do that over here too, negative 5, and I have to come back to this positive sign here. Negative 5 plus 5 is 0. So this is going to be plus 0y equals, I have negative 16 plus 31 equals 15. So another way to rewrite this is 5x is equal to 15. And if I have 5x is equal to 15, divide both sides by 5, and I've easily found that x should be equal to 3 using the elimination method. So I know that in my ordered pair, I should have 3 comma something y. Alright, if I know that we think x equals 3, then I'm going to pick one of the two equations to go, one of the two original equations, either one of these, to go ahead and solve and substitute back in 3 for x, since I know that 3 should be equal to x. And I'm just going to pick the second one because I think that that one looks easier. So once I have x is equal to 3, then I'm going to say, well, 2x plus 5y is equal to 31. I'm going to take out that x, and I'm going to put in what I think x is equal to, which is 3. I'm going to solve this down. This would be 6 plus 5y is equal to 31. Subtract 6 from both sides. 31 minus 6 is going to be 25. So I'm going to have 5y is equal to 25, and y is equal to 5. So I'm assuming here that x is equal to 3 and y is equal to 5. You can see I've written it correctly in my ordered pair, where x comma y. And in my green marker, then I'm going to go ahead and quickly show you how to check these again. I had to check it with both of the equations. I'm going to do that down here in the right hand corner. So I'm going to take out the x's and the y's and substitute in what I think that they are equal to. So 3x minus 5y equals negative 16. And take out the x. I'm going to put in 3 minus 5 times 5. And I think that should be equal to negative 16. This is going to be 9 minus 25. Does that equal negative 16? It sure does. That's negative 16 equals negative 16. So it works for the first one, but that doesn't matter. That just means that this is a solution to that first equation. In order for this to be confirmed as a solution to the system, it has to work for the second one as well. So I'm going to have 2x plus 5y is equal to 31. And I've got to say 2 times 3 plus 5 times 5 should, I put that question mark above, equals 31. So this is 6 plus 25 equals 31, and by the power of addition, I know that 31 equals 31, and it works in both equations. In that way, then, I can check both of these off. They are both, it is both a solution to both those equations, so it works. So my answer here is 3 comma 5. 3 comma 5 is the solution. Alright, so let's take a quick look at another example, example 2. It's just given to me in a little bit of a different format here. Here I've got 2x minus 3y equals 1. I'm just going to rewrite this down below here. 2x minus 3y equals 1. And this blue equation I'm going to write beside it over here is negative 3 equals negative 7y plus 2x. So this isn't necessarily yet in standard form. If it's in standard form, it will be the x term first, then the y term equals the constant. This blue term is backwards. So I'm just going to realign things here. So I have a 2x here minus 7y. And I've just taken that right side of the equation, I made it the left side and reordered the terms, equals negative 3. Now by doing that, I put them both now in standard form, and I can see that I don't have any additive inverse terms here, meaning that the coefficient of 2 is not, or the other one is not negative 2, and this is not 3 down here, but these are the same. So if they're not additive inverses, what I can do is I can subtract. I'm going to subtract the entire equation. So when they're additive inverses, I add, but when they're not, or when they're the same here, I subtract. When they're additive inverse, when they're opposite, I add. When they're the same, I subtract. So here I'm going to take 2 minus 2. 2 minus 2 is going to give me 0x, and I've eliminated that x term. But I have to remember to do that for all of these. So I'm going to have negative 3 minus negative 7. Negative 3 minus negative 7 is the same thing as having negative 3 plus 7. So it's going to be positive 4y. And then I have 1 minus negative 3. 1 minus negative 3 is the same thing as having 1 plus 3, which is then 4. Okay, so then I have 4y is equal to 4, and divide both sides by 4, and y is then equal to 1. So I think my ordered pair is going to be something, comma, 1 for that y. Alright, if I know that, or if I think that y is equal to 1, I'm going to substitute back into one of the original equations. I think either one would definitely work here. I'm just going to pick that first one though. Again, it doesn't matter which one I pick, I just choose whichever one looks the easiest for me to do. And I'm going to take out the y term, and I'm substituting in a 1. So here I have 2x minus 3 is equal to 1. Adding 3 to both sides, because that's the additive inverse of negative 3. Here I've got 2x equal to 4. Divide both sides by 2, and x is equal to 2. Or so I think. I'm going to go ahead and I'm going to substituting using my green pen. And I have to make sure that each one of these, this order pair, this 2, comma 1, is a solution or satisfies both of the original equations. So if the first one was 2x minus 3y equals 1, I said it was 2, 1. would say take out the x, put in a 2, take out the y, put in a 1. I'll have 4 minus 3 I think equals 1, and I do know that 4 minus 3 is 1, so this is 1 equals 1. This first one works. I can't just stop here, I have to do it for the second one as well. So negative 3 is equal to negative 7y plus 2x. And notice I'm pulling it from the original equation I had, this one up here, because this way I'm less likely to make a small error and get a false positive. So this is going to be negative 7 times 1 because that's the y, plus 2 times 2 because that's the x. Move this down a little bit. Not so much. Alright, and so I think that these are equal, and I have negative 3 equals negative 7, I think, plus 4. And so negative 3 is equal to negative 7 plus 4 is negative 3. And so that one works as well. So before I even move on to the next example, I know that my answer here is correct because this ordered pair, this 2, 1, is a solution for both of the equations in the system. So let's take a look at a word problem here, if I can get this thing to go. So the word problem I want to look at says, it's example 3, it says 4 drinks and 4 slices of pizza costs $8 total. 2 drinks and 4 slices of pizza costs $6.50. So I'm going to just try to zoom out here. You're going to see some things happen to the screen, and that is okay. I'm just going to go ahead and go back down here. So here I've got 4 drinks and 2 drinks. So I've got the number of drinks. What I don't know is the cost of the drinks. So I'm going to say that, I'm going to use black pen here. I'm going to say that x is the cost of drinks. I know the number, I just don't know the cost. And I can see that I have 4 slices of pizza. And what do I have here? Another 4 slices of pizza. So I know how many, the number of slices of pizza I have. I don't know the cost. So I'm going to say this is going to be the cost of pizza. And once I have those variables defined, then I can write my equations. I know if I have 4 drinks, that's 4x. So 4 times whatever the cost of each drink is. 4x plus 4y, so 4 slices of pizza is $8. And 2 drinks, so 2x plus 4 slices of pizza is equal to $6.50, or 6.5. Okay, now I'm looking for either the same coefficients or additive inverses. If they're the same, I'm going to subtract. If they're additive inverses, I'm going to add. And here, 4 and 2 don't work, but I've got 4 and 4. So these here are the same. Since they're both positive 4s, I'm going to subtract. Same as subtract. And 4 minus 2 for those coefficients of x is just going to give me a 2x. 4 minus 4 is going to give me a 0y. And then keep in mind, I have to say 8 minus 6.5 or 6.5 is going to be 1.5. And so what I've found here is that 2x is equal to 1.5. 1.5 divided by 2 is 0.75. So x, we said when we define our variables, is the cost of the drinks. So each cost of the drink is 75 cents. I'm just going to start my ordered pair up here. That was x, so that's 0.75. I need to go back and figure out how much the cost of each pizza is. So if each drink is 75 cents, then I can use, let's use the first equation. So we're going to just pick 4 I know x is 0.75 plus, I'm going to come back here with a different colored pen, equals 8. I'm choosing that first equation. You can choose either one. I'm choosing the first one just because of the whole numbers here that I'm dealing with. It's going to be 0.75. So 4 times 0.75 is 3. So if I have 75 cents is $1.50, another 75 cents is $2.25, and then another one is $3. So this is plus 4y equals 8. Isolate the y. Notice I don't know what y is equal to yet in my ordered pair. Back up over here. I know what the x is, but not what the y is, and I'm trying to solve for y. Again, another quick mental check to know that I'm on the right track. Is equal to 5. Oh my. And divide both sides by 4. And y is equal to 5/4, or if we're talking about money, that's going to be $1.25. So I think then that the y is equal to 1.25. What I would challenge you to do right now is go ahead and substitute in that 0.75 for the x in both of the equations and that $1.25 for the y to confirm that those are the correct answers. Go ahead and do that, and then you can call it a night, and I will see you guys in the morning.